Well, good morning or good afternoon, wherever you might be. Thanks very much for joining us on the second edition of our webinar series, Turning Maintenance Data into Action. This week, we've got, are you improving equipment health or monitoring to death? We've got our panel, two panelists so far as our usual panel from the first one, Matt McLeod and Angus Lay. What we're focusing on is about using data to take action. And we know that there's a lot of monitoring that happens on site with equipment, but getting full value from that monitoring is actually putting that into action. So it's turning that valuable information, and there's so many different sources now of data, and it can be quite overwhelming, whether it's onboard data, oil sample, vibration data, whatever it may be, it's what you do with that. So there's a real danger of over monitoring without actually taking any action. Now, just quickly, an intro. I'm Osman Bohemia from Relialytics. Matt McLeod is from Bluefield Assets, and Angus Lay is from Relialytics as well. And Matt will go through a little discussion about their experience. A little bit about Relialytics for those of you who are not familiar with who we are. We're a Brisbane-based company, and we help reliability and maintenance teams prevent component failure by using data to take action, using our Equipment Condition Supervisor, which is a program that we deploy for maintenance and reliability teams. So if anyone wants more information, feel free to contact me, but today we'll focus on condition monitoring. This will be a very conversational webinar. It won't be a long-winded presentation. And in this webinar, what we'd like you to do is use the Q&A through the discussion that Matt and Angus are going to have, and ask a question. So you don't have to wait to the end. Say something that you feel you'd like to comment on, and we'll raise that. You can do that anonymously if you like, or you can put your name to it. It's up to you. But the idea is to make this very conversational and engaging. So feel free to put your 2 bobs worth in, and then we'll try and address that as a discussion. And I also know there's a lot of people who will watch this as a recording. So welcome to you all who are looking at it as a recording. So we'll kick off. I'm going to introduce Matt to take this from here. And Matt and Angus will have a discussion. And as I said, please feel free to use the Q&A button and pitch in and have your say. So I'll leave it with you.
Thanks, Oz. Welcome, everyone. Thanks for joining us this afternoon. And as I said, we won't be having a long-winded presentation, really more of a conversation between Angus and myself. So firstly, why is this topic so important? And we all know we're all in the same industries together. We've got plenty of data, so much data we really know that we're not getting the best bang for our buck out of it necessarily. So you're supposed to be doing something with that data, but a lot of people are wondering whether they're really getting a good return on their investment. So that's the time you're investing in your program and the money. It costs money to do some of this as well. So are you getting bang for your buck in your condition monitoring program? So with me today is Angus Lay. He's a senior analyst at Relialytics. And as you can see from Angus's background, he's got a lot of experience in the field, 16 years in the marine industry in a variety of positions, ALS tribology, as a diagnostician. So Angus has got certainly a lot of depth of knowledge in oil analysis. Dingo for 3 years, 5 years running the asset health team at Peabody, and more recently at Relialytics. And myself, I've got a mechanical engineering background. I spent 12 years with Caterpillar, a few years in coal mining, a bit of time at fixed plant, and then a couple more years in trucking and off-highway engines, and more recently at Bluefield as an asset specialist too. So we're just going to have a little conversation about these 4 points here, and we'll get into them in a second in each of the following slides. But again, as I said, we'd really like to encourage you to jump in at any time. Use that little Q&A button at the bottom of the Zoom screen here. Click that and just jump in with a question or a comment at any time, and Oz will interrupt us or stop us at a particular point, and we'll try and address those issues as they come up. Okay, so if you're not taking action, then really why are we bothering to monitor equipment in the first place? So I guess I've just we'll solicit some feedback from Angus into what are the common impediments to action, and then how can condition monitoring analysts and planners and supervisors in those middle management sort of roles, how can they help their teams to drive action? So Angus, over to you for a second.
Okay, yeah, thanks, Matt, and good afternoon, everyone. Yeah, I mean, probably one of the biggest impediments to action is just the sheer volume of data that is now available or comes through, on a daily occurrence. I mean, with live machine data, the potential for one fleet to produce 6,000 alarms in one daily report, determining out of those 6,000 alarms, which are the criticals that need to be actioned, can be extremely difficult, and understanding what needs to be done as well, what's driving that alarm, the root cause, it's not always apparent. And that's no different with all samples. We find that there are good Bs and there are bad A samples. There are even good Cs, but which ones require the immediate action, and what can wait to the next PM, and what action do you need to take to address the underlying cause? I mean, some samples it's quite obvious. Fuel dilution 10%, we know that needs to be pulled up straight away, but others cannot be. Others are not so obvious, and it can be a very can be very difficult to determine what needs to be done and at what priority it needs to be done at. Another thing is pushing components for all sort of looking for to get a better life out of the components. That can introduce new failure modes that we're not currently aware of. So if you're not looking for the real sort of the early precursors of the evidence that in the A samples, then they can quickly run through to failure without very, very little to no warning. Another issue is depth of knowledge. Most mine sites now operate quite a large variety of equipment, from Liebherr to Hitachi to Komatsu, Caterpillar machines. So, and with those different OEMs and different machines, there can be quite different failure modes. So being on top of all that can be, again, you don't always have the depth of knowledge there to be able to identify those issues or understand what to be done. So in those circumstances, I'd really recommend if you are looking for a particular new failure mode they're not aware of through the oil sampling or through the machine data, lean on your OEMs for advice, and obviously get their assistance to help address those problems. I mean, that's what we're here to do. One big issue that I see that is what happens, a large percentage of the time, is we get stuck in the resample and oil change loop, but don't actually address the root cause. So we just essentially do monitor it through to death until the component blows up. One problem with that is we're not capturing the required feedback from the guys on the floor, or what was done or found. If we don't do that, then it makes it very difficult to get out of that resample change, or if you're asking for the guys to on a fuel dilution to check the telltale on the fuel pump and they're not providing that feedback that they did it, then you can't move on to the more in-depth inspections where to try and identify where that problem is occurring or what the root cause is.
Yeah, sure. So what happens then when an equipment or when an organisation becomes totally reactive?
Yeah, look, honestly, any site that's reactive to Cs and Xs only, or the red alarms on the machines, or that you are in a reactive environment, a lot of the problem that drives that to maintenance departments now, they simply just don't have an excess of arms of legs anymore. When you're in a breakdown reactive environment, the labor to fix the breakdown is typically coming from your planned maintenance, because you've got to pull, if a digger's broken down or a truck's broken down under the digger, which is where they typically seem to do it, or the middle of the haulway, you've got to get that thing fixed and running and back up and running as quickly as possible. Otherwise, you run the risk of production delays and or loss of production, I should say. So when that happens, though, is if you're pulling your plan maintenance, your guys off your plane maintenance to go do these breakdown events, that results in the defects that were potentially planned in on that service being pushed out, so the next service, or not done at all, and also potentially services being pushed out as well from their normal routine, which just once that starts to happen, it really does sort of snowball. And if you're not fixing your defects, you're not doing your planned maintenance on time, and you tend to end up with a lot more breakdowns. So it just exacerbates the problem. Also, the cost of the breakdown can be anywhere from 2 to 3 times more expensive than a planned repair. And breakdowns also tend to, as I sort of previously mentioned, they normally happen in the most inopportune time, and under the digger typically. That can result in a lot of pressure being put on the maintenance team to get that machine up and running as quickly as possible, which can result in rushing, poor decisions being made to get it running. And when that happens, it can significantly increase the risk of potential safety incidences from happening.
Angus, I've got a question that has just come through, and it's also probably relates to the earlier slide, and I think you may have sort of answered it in what you've said, but it asks, I often hear people say that we cannot yet do the basics and we are not yet ready to action oil sample reports. Is this not one of the most basic things that can be done? And how is it possible to overcome this perception that taking action to oil samples is a higher level task?
Yeah, look, absolutely. You need to be doing the basics really well, and that starts with the right oil, the right time, in the right compartment. You really need to focus on, and getting, the samples taken well as well. I mean, a lot of sites don't really have have a lot of focus on taking the samples or taking them well. And a lot of that can boil down to and what I have seen is that, a lot of the time the guys taking the sample don't understand the importance or the criticality of what they're doing, don't understand the contamination control that, introducing a bit of dust or water into that sample, or taking the sample directly from the drain bung without letting it drain, previously, or best practice is taking a live sample. If that happens, potentially you're all sampling, you're going to be chasing, bad samples, but you have to react to it because you don't know the difference between a bad sample. A spike in PQ could be potentially describing something that's failing inside that compartment, or it could just be a poor sample. But either way, you've got to send someone out to then take another sample to confirm, which can sort of really erode the trust in the program as well. And it's why a lot of sites just simply focus on the C's and X's because of that noise in the A's and B's.
Yeah, and I think also, I mean, what you were saying previously about having a breakdown under a digger. I mean, if there's no more motivation to use your oil sample reports, that's got to be one of them.
Yeah, absolutely. I mean, it's rare that you get a component that'll go straight to an X sample. Generally, with most failures, there's plenty of evidence leading up to it before it gets to that point.
Very good. Do we cover that question completely, Oz?
Yeah, I think so. I think it's very much about raising the perception of the importance of oil samples as a method of really preventing failure.
Sure. And if anyone feels like there's more to the question or they didn't get a complete answer, please, Oz's contact details are at the end of the slide. By all means, get in contact with us and we'll endeavour to get you a more complete answer. Okay, next question. What sort of structures and resources help drive proactive behaviours, Angus?
Yeah, look, I mean, one thing that, everyone needs to understand the expectations of the program. That comes down to responsibilities and accountabilities. I mean, everyone needs to understand their role in the whole program, from taking the samples to reviewing them, providing recommendations, and that sort of expectation or accountability to sort of drive that feedback from the workshop floor of what with a particular issue that was identified. We need to know what out of the recommendations, what they actually did, what they found, and if they didn't find it, we need to know that as well. That's just as important, because it means that we need to try harder and look, dig deeper to find the root cause of that particular problem. 9 times out of 10, that's not the case. You generally get it on the first sort of notification where we've confirmed that there's an ongoing problem. But if obviously sometimes you do have those cases where they can be more difficult to identify. So we need to have that good communication and feedback in, so that we know what was done and what we need to do differently. You know, like I said, if feedback is absolutely critical to success, you know, you really do need to understand what was done, you know, and did it fix it. If you can't get that basic information, then it makes it very difficult to obviously fix the root cause of the problem. And again, you get stuck in that resample, you know, change oil sort of loop where you're not actually fixing the problem, you're just band-aiding the outcome.
Yeah, that's very true. Okay, and our last question we just want to discuss is what sort of elements contribute to long-term success with any condition monitoring program? What, in your experience, Angus, anyway, what you've seen?
Yeah, I probably already touched on it previously through the question that was asked, but yeah, it's the basics to, you know, a successful program is doing the basics exceptionally well and driving consistency in everything you do, from, you know, like I said, the clean oil, the right time, you know, sampling program where the guys, you know, well trained, know how to take a good consistent sample. You know, they're taking that sample from the same point, the same way, you know, as often as possible. Obviously, there are some restrictions which can prevent that, but that happen from time to time. But yeah, it's all about that driving consistency, and then you can start to focus on what the problems are. You know, again, if you're already getting live machine data from your equipment, first step in that is around that consistency, and you'll find that, you know, first step is fixing the sensors, because there'll be a lot that don't work or reading correctly through, you know, sensor problems or harness corrosion issues. And, you know, if those sensors aren't reading correctly, you potentially run the risk of you know, a component failure with zero to prior warning, because the OEM alarms are based, you know, looking at that sensor for a trigger. You know, one example of that was a, you know, a crankcase pressure sensor that was reading off negative base. Now, the fact that it was reading off a negative base meant that by the time it got to the OEM alarm, that engine was really in a very poor state, and you know, potentially you know, could have failed in service if not identified. So it's really about getting those sensors working properly. Sampling program is done exceptionally well. The guys understand the criticality of taking a good clean sample. You know, the other thing is, you know, if you're embarking on this journey, you know, currently or have a program underway, you know, one sort of key takeaway I learned early on at Peabody was, don't try and boil the ocean. You know, start small, get the rungs on the ladder while you build trust with the maintenance team. You know, everyone needs to be on that same journey, and if you try and run before the guy or before the maintenance team can walk, you just the program won't succeed. It's really important that, you know, this is just not you know, something you can do isolated. It needs to have the support from the team on the floor, right through that maintenance department and operations as well, because yeah, there's certainly a part that they play in this picture as well.
I think that goes to, I mean, I made a note there, is the importance of culture. And, you know, you can implement all of the technology and plans, but it's having the right culture and everyone understanding the benefits of the journey that you're on.
Yeah, we've certainly done a few projects like that in the Bluefield world. We're helping operations with a culture driven by what's happening from the floor up, not from what management, you know, thinks the best approach, and pushing that down. I think also, just to add to what you've said, Angus, in this respect, is I think the right metrics are going to be helpful to a condition monitoring program. And one really good one that I've seen used at an engagement I had a couple of years ago was they called it runtime after service. So it was how many days did that machine stay out in the field after the service was done. So, and everyone was on board with that, the whole organisation from the floor to the maintenance manager. Everyone was looking at that number, and it was, if we do a good job with the service, and if we do a good job with defect identification and defect rectification, that includes, you know, what you found with condition monitoring, and let's focus on that as a metric. And over time, we had machines that would quite happily run service to service without a single breakdown, which for that fleet was a big turnaround.
I think we'll go on to we've got some more questions that have come through.
Sure.
So we might just grab some of those questions. So I guess this is to both of you. have you ever seen a site that has had the courage to stop taking the samples because they know that no one is actually taking the necessary action? Which my first response would be, I'm not sure if I'd call it courage, but yeah, have either of you or anyone who's in the audience there had any experience with just shutting down and not doing any sampling?
I challenged an operation once to stop doing oil sampling because they were spending a lot of money on it and weren't getting a lot of value, and they didn't have the courage to stop.
Yeah, look, I've told sites to stop sampling certain equipment because the money they were spending on sampling just didn't have the return on investment. For instance, they were sampling every engine from the lighting plants, so they had about 120 odd lighting plants across the site. The engine in that particular lighting plan was worth about $4,000, and it's not a really high ticket, high value item. And they were sampling every 2 weeks, so they were spending about $15,000 a year on sampling to save potentially one engine a year. Which so I mean, you've got to make sure that you're not over servicing or over sampling for those reasons. That if the component's only a very low cost or low value item, you could potentially spend 3-4 times as much in sampling than what it would cost you if you let it just run to fail. And being a lighting plant, I was surprised that they were sampling it when I first sort of started looking at the data for them. But that was one of my recommendations straight away, was to stop sampling, because you're actually wasting money in that respect.
So it's almost as if you're better off working out what will you be able to action and what's critical, and then sample those. So you're actually using that data to put into action rather than have an all-encompassing sampling program with a heap of data, which we've talked about, that you don't actually use.
Yeah, exactly. And those samples coming through were sort of taking up time for people to review and analyze. But it's just not providing any real sort of economical sort of value. If to prevent one failure a year, which was worth $4,000, it just wasn't worth the time and effort. Yeah. I've never had a site where I've apart from those sort of scenarios, but I've had sites that were very, very bad at oil sampling. In fact, they didn't know who were taking the samples. They had contractors taking them. They didn't know who was responsible for actioning the results. And we sort of moved in and took all that work on board for them as a centralized asset health group at Peabody. And we initially looked at it. They were around about, and I kid you not, 40% of their samples were critically rated, or X samples from the lab. So they're in a very, very bad way. It didn't happen overnight, but within 18 months, we had that site, at 85% normal, about 1% critical. So really big turnaround. And that was an underground operation where the maintenance manager at that site said, "Look, you don't understand. This equipment runs in water, and it's always bad, and the conditions are always poor." And I said, "Well, let's see what we can do there." And like I said, it was by really focusing on and driving the right behaviors and actioning and getting on top of this, we really were able to turn that site around. But that was also through the engagement of the guys on site. We developed really good relationships with the team, and that certainly, like I said, it took 18 months, but we turned that site around to a point where we're able to actively identify issues and help manage them through until longwall change, or a period where they can actually get to that particular component, because you can't always get to a tail end gearbox on a longwall there and then. You've got to wait for an opportunity to get to that point and do it. And we were able to help them successfully manage those components through to a point where they could get them out in a planned downtime.
Okay. Another good one here, actually. With all of the more proactive actions, such as fixing small leaks, and making sure the right oil is in the right compartment all the time, how do you measure the benefit of all of those small actions that may not get a priority?
Yeah, look, what we used to look at sort of the remaining life of that component. and the issue that we were addressing, so it was a dirt entry, fuel dilution, or whatever it might have been, we'd look at the potential chance of that component failing in service if we did nothing, and we would then calculate a cost saving or cost avoidance from that, based off the rebuild cost of the particular component and the remaining value. And that we used to sort of report that through the business, because you do need to sort of justify the work that you're doing, particularly when everything's running really, really well, because you know, the bean counters start asking questions on what is this group doing, or what do you guys do? So it's really important to be able to report that, or record, you know, the good work and the success. And we also used to report sort of fleet health as well. So we'd aim for a benchmark of 80% normal and 18% caution, and no more than 2% of components in critical, and maintain that, so we could show that sort of value to the through the business that we were managing our equipment well.
I guess, you know, also to that point, Angus, is that measuring the benefit would be the reduction of the overall reduction in the critical and urgent in terms of oil samples. You'll see that you won't get as many, and I guess that leads into another question here is about prioritizing work when you have a lot of critical and urgents that are coming through, but you know that to prevent those from happening, you have to do the things like fixing small leaks and doing all of those small things. So how do you know where to start when you've got all of the critical things that need to be done? How do you do the small things? It's a bit it seems like a bit of a catch-22, doesn't it?
Yeah, well, definitely when you first, you need to be, again, when I talked about, that you've got to sort of get the rungs on the ladder. Typically, with that underground operation, we didn't sort of start off full steam ahead and flagging everything. We focused on the criticals first, and we obviously had a much higher tolerance for issues initially, and as we improved the condition, we then sort of tightened that up and consistently sort of turned the screws to get them down from what we initially would say anything under 1% water, just ignore it. Not ignore it, but we're not going to raise an avocation, because we need to fix the gearboxes with 5 and 10% water and they're generating a heap of wear. So, you've got to start, certainly address the big issues first, get that trust, get those resolved, and then slowly work through the problems. If you try and go full bore from the onset, typically, if we 50% of the samples critical, 40% I should say. If we were to throw every work order into the system, that department just would have fallen over. So we needed to be very careful that we started slowly and got the big issues resolved first, and then slowly worked our way around. I don't see a caution. Cs and Xs are typically, like I said, they're reactive. You're already taking life off the component, or you're managing a failure. The value, or the real value, is in the caution samples. So something that is the early indication. If we get it there and then, it'll prevent it from getting to those Cs and Xs. But when you're in a highly reactive state and everything is an X, you've got to focus on those first, obviously.
Okay. I think to add to that, there are going to be cases when you're going to have to campaign machines or campaign a part of your fleet if they're in that bad a performance. You're just simply not going to be able to get in front of it with the existing resources that you've got. So I've certainly been involved in exercises where you need to campaign machines. That means very good planning, very good parts management, and extra labour for a small period of time to get on top of all those defects. But I think to the question, it was about quantifying some of those proactive actions like fixing leaks. I think that measure, like runtime after service, or MTBF after PM, whatever you want to call it, that's one way you can say, well, if I do this work now while I'm in the controlled workshop environment, can I offset a potential failure in the future, which is going to, short duration downtimes are, availability killers. So some of those things are ways you can measure that type of behaviour, or the effect of that type of proactive behaviour.
Excellent. So I think we're bang on 30 minutes. Thanks for everyone for joining us. If you have any other questions, feel free. My contact details are on the screen. Feel free to contact me. So thank you, Angus and Matt. And if there's anyone who'd like a bit more information on what we do and how we can actually help you deal with some of the issues that Angus and Matt were talking about, with using that data to put it into action, and making a difference to your reliability, yeah, also feel free to contact me and we can have a discussion about your unique circumstances. So everyone will get a recording of this, and I'll send the presentation, and we'll also include some notes in there with some of Angus's answers, so you'll have that to refer to or share with your team. So thank you, everyone, and have a good Christmas and New Year. And we'll pick up the third edition of this in the new year. So we look forward to talking to you then. So thank you very much.
Thank you.